Today on NerdOut, Yubikey Cardano wallet. Welcome back to NerdOut, the show where we take a look at Cardano, we break it down, but we don't dumb it down. Today we're talking about trying to use Yubikey as a Cardano wallet. So this will be a deep dive. Let's get into it. So the rabbit hole I decided to go down, I was realizing that Cardano uses these ED25519 key signatures. Yubikey also supports ED25519. I have a typo there, and it has 3 key slots on the Yubikey. So I'm thinking you got 1 key for payment, 1 key for staking, 1 key for governance. Boom, Cardano wallet. And so this is what we're trying to do with going down the rabbit hole. Is my original goal was to try and convert a mnemonic seed phrase into something that could be loaded onto the Yubikey. And then I wanted to also see if we could get any type of private key onto the Yubikey, whether that's generated with the mnemonic phrase or not. And then the final thing we want to try is, can we sign a Cardano transaction with the Yubikey device? And as you can guess, this was a very deep and long process for me. So I have the 12 hours later meme here. And as you know, I don't need more projects, so time boxing these things is very important to me. So I spent all yesterday going down this rabbit hole. So let's first talk about Mnemonic Seed onto Yubikey. How do we get the Mnemonic Seed phrase and then convert that into something that can go onto Yubikey? So we started with our tried and true utilities from input output. These are Cardano address and Cardano CLI. You can use those to generate a recovery phrase, a seed phrase, and then you can go from seed phrase to root key. You can go from root key, derive the account key, and then from the account key, you can derive a payment secret key, and then you can use Cardano CLI to go from that key into something you could use with Cardano CLI, and that will give you this payment extended signing key Shelly ED25519 BIP32, which is the key derivation algorithm. And so this gives you a 64-bit key, and then it also includes a chain code at the end, so it's a little longer. But the main raw key is the first 64 bytes of it there. And so that's what we wanted to try and get onto a Yubikey. So that being said, trying to load the seed onto Yubikey, I was not successful. The reason for that is the Yubikey doesn't actually store the raw key bytes. There's no way to put the raw bytes onto the Yubikey as far as I know. It doesn't use raw keys. It uses instead its own key derivation function. And so that's called S2K. And what that does is your key is actually a password. It combines it with a random salt, and then it hashes that repeatedly so many times to prevent dictionary attacks and other things. So it's a different algorithm for going from, like, we use mnemonic seed phrase so that we can derive these keys, and they use this password and then use this algorithm to get a key out of that. And that algorithm and the algorithm parameters are what's stored on the key. So there's no way to go from mnemonic phrase to something that goes onto the key. But we do have, with the Yubikey, you can load PGP keys onto it because it has a smart card interface. But again, I said you can't load the raw key bytes like we have on Cardano. And so then I was thinking, okay, well, if we can't go from mnemonic seed phrase to the Yubikey, can we just go from an OpenPGP key we generate, get that on the device, and then use it to sign a transaction? So first we need to talk a little bit about how Cardano signs a transaction. So Cardano signs a transaction by first looking at the transaction body CBOR bytes. So there's the body of the transaction. That's where it specifies the UTXOs you're going from, the output UTXOs, any change, any metadata hashes, all of that stuff goes in the transaction body. And then those bytes runs through the Blake 2B 256 algorithm. So it crunches it down into 32 bytes with this Blake 2B 256. And that hash is what's known as a transaction ID. So whenever you're just using your wallet and you submit a transaction and it shows you, hey, what's your transaction ID? That's actually the hash of the body of the transaction you built. And when you sign a transaction on Cardano, that hash is what's actually signed. So you take your ED25519 private key and then you sign the transaction ID bytes, and that creates a signature. And that signature plus the public key are then attached to your transaction body, and that converts it from a unsigned transaction into a signed transaction. And then that whole thing as a big CBOR blob gets submitted to the network, and then any other nodes can verify those signatures that, you know, yes, this key that, or this signature is allowed to sign this particular UTXO, and then so the whole transaction can get verified that way. So that's how transaction signing works on Cardano. So let's move over to OpenPGP and see if we can just use an OpenPGP key to sign a transaction. So PGP is designed to sign files or email messages. It's sometimes used to, you know, sign GitHub commits, or if you want to sign an email message to prove it came from you, you can use PGP to do that. And so my thought was, if we could store our transaction body CBOR just as, you know, the binary message we're signing, maybe it could work. So unfortunately, PGP does force hashing of the data before it signs. And then if you look at the version information under hashes, it supports SHA-1, RIPE-MD 160, SHA-256, 384, 512, and 224. It does not, unfortunately, support Blake 2B. And so I looked at that and was like, okay, well, what if I just tell it to not use a digest algorithm at all? What if I just tell it, go ahead and sign whatever raw bytes I'm giving you, to sign the file directly? And there was no option, unfortunately, in GPG. Like, I tried digest algorithm none. I tried to disable the digest algorithm. There's no options for any of that. So the GPG command is not able to do any type of raw signing, or it doesn't support our particular Blake 2B hash function that we would need in order to get a Cardano transaction signed. So what are some of the takeaways? One of the takeaways is, even if I go down a rabbit hole like this, and even if it's not successful, I'm still going to try and share it with you, the community, because I did spend a lot of time on this, and even though it wasn't ultimately successful, I had a lot of learnings from it. So I learned all about the PGP file formats. I learned how to load keys onto a Yubikey. I learned actually how to manually sign a Cardano transaction with an extended key that is used from those derivation paths, not just a simple enterprise key that I typically have done in the past. And I also learned a bit about the S2K key derivation algorithm, and probably a bunch of other stuff I'm forgetting now that, I went down paths that ultimately didn't work out. But if I did miss something in this video and you have a better idea for how to unlock the Yubikey for usage on Cardano, definitely let me know in the comments below. Again, thank you for watching, and with that, nerd out.